This is a lesson video to go with 5-6. It's related rates. It's example number 5, the trough. And again, if we want to think about permanent, instantaneous, and what are we trying to get, or any other way you want to say that, when you read through the problem, swill is what fills a pig trough, and it's all different combination of foods that they feed to the pigs. It's the leftovers. So as they describe this trough, it's a prism, and every slice of the prism would appear like that triangle that I've got sketched. So I want to have a sense of how that works, because then the volume of that triangle's trough will be the triangle times the 10 feet from front to back on that trough. So what are we trying to find? As you read through, they want to know, how is the swill level changing? How fast is it changing? dH dt. At a time when its height is exactly 1.25 feet. And I would switch to 1.25 feet because with feet and inches, we're going to have a units issue. So stick to 1 unit, and 1 feet 3 inches goes nicely into a decimal number of feet. So what's fixed? Fixed in the situation for sure is that relationship between the base and the height. That triangle is always going to have a similar triangular prism filling in the trough. And therefore what's fixed is that I know that the relationship of the base of that triangle to the height of that triangle will always be in that fixed ratio of 2 to 2.5, or 4 to 5. So as I go about doing things, I know that 5 times the base will always be 4 times the height. That's going to help me later on when I might need to get some dB dt or dH dt's and things like that, but that's definitely going to help with that. They also tell me that as they're adding the swill, which will change the volume, that the volume is changing at a rate of 5 cubic centimeters, or 5 cubic feet per minute. And since that's in feet, it's a good thing we changed all those other measurements into feet. At that instance in time, there's some things I know. They want to know when the height is exactly 1.25 feet. When that's true, if I solve, I can get the base length, going back to the fact that 5 times the base is 4 times the height. So if I go back to 5b is 4, 1.25, it ends up that at that exact time the base will be 1 foot. Now I need to think about the relationship for how this swill trough is even having its volume change, and therefore I want to look at rates of change for the volume of that trough. Since it's a triangular prism, it'll be the area of the triangle multiplied by that depth, or from front to back, which is 10. And that's this piece right there. Okay. So as I go to do this, I want to clean this up a little bit first. Volume is going to be 5 times base times height. At this point, you could make your life a heck of a lot simpler in this problem and simply substitute this 5b equals 4h. That's a fixed value. It's not a one-time value. And if you notice, we have a 5b right in there. And I'm trying to find dH dt, so it's okay that I would leave an h behind. So I'm going to sub that out to make my life a little simpler. Instead of 5b, I'm going to put in 4h. My volume equation now is 4h squared. It's going to make my calculus so much simpler because I only have one variable besides volume then. Again, if you don't do that, that's fine. You end up just needing some rates, and those rates you'll have to come back here and take the derivative, so you'll have dB dt's and dH dt's. So how the volume is changing as a factor of time then would be 8h dH dt. So again, you wouldn't have to do that swap out for the 5b's. It just makes the calculus much simpler, and this is going to go much faster. It would still work, however, using product rule with b's and h's and coming back to here and getting your dB dt's, dH dt's relationship. So I do happen to know that the volume of the swill filling it is positive 5. And I happen to know that at the instance in time when we are at 1.25 feet in height, that they would like us to solve for dH dt. And as I do that, I'm going to get that 5 equals 10 dH dt. And I get that dH dt is 1/2. Making sure that I answer the question, when the height of the swill is 1.25 feet. The rate of change, or what it's rising at, is half a foot